Welcome back to my YouTube channel. So today we're going to go over 3 topics that you guys have asked for, and it's all going to be about forecasting. So in the first topic, we're going to be talking about selecting a forecast method and how do you go about doing that? What are your options? How do you decide what's your best method? And then number 2, we'll go into creating a forecast, and we're going to discuss just one type of forecast for this video, and that's going to be the winter's forecast. And I'll show you why during the first step. And then in step 3, we're going to take a look at evaluating the forecast and taking a look at its accuracy and how do you interpret that accuracy and what does it all mean. So we'll just jump straight into it. Here on my Excel workbook, you can all follow along with me. So I have 3 columns. I have A, B, and C. A, I have date, and it looks like I have year, and then month and day. And then over in B, it looks like I have a product called Sneezy. And then C, I have a product called Breezy. And these 2 products are allergy medicines. So we have Sneezy and Breezy, and then their sale volume as it goes down. And so what we want to do is we want to predict what's going to be happening 12 periods after this data. So that is 1 year's worth of forecasting. 12 data points, each one's a month, that's 1 year. So we want to figure out, what is that going to look like? How much should they be stocking? What do they anticipate their sales going to be? How do they anticipate to grow? So we need to take a look at what kind of forecast method we need. So that's number 1. Select the forecast method. So you'll select your data. We'll do A, B, and C. You'll go and you'll insert a line chart. A nice way about doing that is that it makes it quite visual. Now, there's 3 main components that you want to look at when taking a look at your data and see what kind of forecast methods you can use. So let's just take a look at our data and see what kind of attributes that we can discover in this. So we see that we have a trend because we start down here and then we end up over here. So we're trending upwards, so we know that we have a trend. So right there, we can say, hey, naive may not be the best one to be doing on this one because we have a trend that's going up. So what other attributes can we see? What else can we help define what method is best for us? Well, I can see quite a lot of seasonality. So if I highlight that, so let's say that we start here from peak to trough. That is 1 period. Okay, so that's 1 season. Oh, look at that. We have it repeating again. We have it repeating again. And so on and so forth. We see these episodes of seasonality. And now, a very interesting one that we can see. So we have trend, we have seasonality. Another attribute that I can see right away is some irregularity. So right here, we have a huge irregularity. And so all that means is that it predicts a little bit different than what you would anticipate it would. As you see on these 2, we see, it kind of predict like a mountain shape. It goes up, it comes down. But this one, it has a bit of a hump to it. And then blue line, it dips. Sneezy dips aggressively before it reaches its seasonal high. So that is what I would call irregular. So with those 3 factors in mind, I would say, hey, for forecasting, I would definitely want to use a winter's forecast. Why do I want to use a winter's forecast? Well, a winter's forecast is just a variation, simple exponential smoothing that can account for both seasonality and trend. How does it do that? Well, I'll show you by showing you the formula. So here we have our winter's forecast. And so it's broken into different components. Each component can handle a certain factor, or a certain attribute, I should say. So this you'll recognize as just being standard forecasting method. So this will just give you a forecast. There's nothing really fancy about it. It can't do seasonality. It can't do trend. It's just simple exponential smoothing. We know that because we see alpha in here, and that's a smoothing constant. If we go down, the next part of this formula, that is a seasonal formula. So that has another smoothing constant. That is beta. And that's gonna handle the seasonality in this data set. And then we have another component, and this is trend. So we saw that it was trending upwards, so we need something to handle that trend factor, that trend attribute. So here we have a trend formula, and here we have another smoothing constant, and that is gamma, the y looking one. And then all those plug those formulas in, and we get a winter's forecast. And that is how you handle both your regular forecast, your seasonality, and your trend. And so this is an excellent method to start with. And we'll talk about what to do after you make your forecast a little bit later. Okay, on to step 2. This is create a winter's forecast. Now we have 2 products here, but when we took a look at them in the data, you can see that they kind of behave differently. You know, they have different demand characteristics to it. You know, people want, sneezy more than breezy, or breezy more than sneezy. So we need to treat them differently. We need to give them different forecasts. We can't forecast them at the same time. So we'll do one product at a time. And then at the end, if you want to see, total inventory that you should expect, you can add your forecast. And we'll see what that looks like later. But for this, create a winter's forecast, one product at a time. So for that, we're going to start with sneezy. So grab A and B, Control C, go to a new sheet. Now, I have some things on here. Don't worry about that. It's just to make things go a little bit quicker. We're going to start in B1. So put everything there. So we have date, we have sneezy. For my own sanity, we're going to make sure that I highlight the different years. So I have some process steps. Feel free to follow along. Let's start with step 1. Label the periods. Okay, we need a place for that. We'll do it here. You can just autofill this. 1, 2, 3. Highlight those and fill those down. Beautiful. Okay, so a period is just a month full of data, or a period of time full of data. So that is step 1 done. Step 2, okay, initial seasonal index. So we need a place for that. So we'll do seasonal index. Beautiful. Okay, D2. Let's go equals C2 divided by average. We want the average of the whole year of 2015. So these 12 periods. Now we also need to lock this figure, because as we drag it down, we want the month to change, but not the year. So we'll close the bracket. And we're just going to drag it down just for the first year, because it's just an initial value. Seasonal index, what this is saying is, if it's less than 1, you're below the average for the year. If you're above 1, you're above average for the year. So it's just a way to account for seasonality. And we're just doing initial values right now. So that is step 2 complete. Step 3 is the initial seasonal adjusted data. So we need a place to put that. Let's put that in column E. We'll say adjusted. So this data is going to be affected by the seasonal index. So because we don't have a seasonal index, to track here, we gotta go down here, right? There's nothing before this. We have no data, no prior season. So we have to go to the next available period in which we have previous season for, if that makes sense. So that is E14. Go down to the next year, that's 2016. Go equals C14, which is the current period, divided by January of the previous season. So that's D2. Perfect. We'll enter that. Step 3, job done. Step 4, initial trend. Find the trend, the initial trend. Okay. So I'll put a place for trend. We'll do that in F. Again, we're going to need to go down to 2016 so that we have a previous seasonal index for. We'll go equals E14, which is going to be the current period's adjusted data minus, open the bracket, C13. C13 is going to be the previous period's actuals divided by D13, which is that same period's seasonal index. We'll close the bracket, we'll hit enter. So that is step 4 done. Step 5, so we're looking at creating a smoothed seasonal index. So before I talked about smoothing constants, this is where they come into play. So we need a place to put our smoothing constants, and I just so happen to have a place for them. So we have an alpha, we have a beta, and we have a gamma. Now, you can just give whatever value you want to these right now, as long as it's between 0 and 1. So we're going to put 0.1 because it doesn't matter at this point. We're going to refine these numbers later. So we have our smoothing constants, And we only need gamma right now, but you're up there making the Excel sheet, so you might as well just put alpha, beta, and gamma in there all at the same time. So smooth seasonal index. Let's go to D14. That is because it is the next available seasonal index spot. We're going to smooth it. So we're going to go equals gamma, log gamma, times, open bracket, C14, which is that period's actuals, divided by E of the same period, so the adjusted data, close bracket, plus, open a bracket, then we go 1 minus gamma, and every time that we use one of these smoothing constants, we'll lock it, close a bracket, times D2. We're doing D2 because we were working in January. We need this prior seasonal index, D2, that's January of 2015. And we'll hit enter. Now for this, we can actually double click and let it autofill because we'll need it down there. We have errors, don't worry about it. We'll fix it later. So that is step 5 complete. Okay, step 6. Step 6 is a smooth seasonally adjusted data. So again, we're dealing with a smoothing constant. We'll work with it in E15. So go to E15, we'll go equals. We gotta pick our smoothing constant. And for this one, we are working with alpha. So again, smoothing constant. Gotta lock it. Times same period divided by previous seasonal index, D3, plus, open a bracket, 1 minus the same smoothing constant, lock it, close a bracket, times an open bracket, E14. E14 is right above it, and then we'll go plus F14, and F14 is right and above it again. Close bracket, equals, oh, hang on, there's a mistake here. Okay, beautiful. And again, autofill it all the way down, and see, fix the problem, beautiful. Step 6, job done. Step 7, okay. We want a smooth trend. Again, this is going to deal with a smoothing constant. We'll go to the next place that we have a trend. So F15. So we'll go equals. Oh, we haven't used beta yet. Let's use beta. Lock it. We'll times that by an open bracket, then E15. E15, same period adjusted, minus same period, or previous periods adjusted, sorry, close bracket, plus, open bracket, 1 minus the same smoothing constant, which we are locking, close bracket, times F14, and F14 is just the previous period. So you may not be able to click on it because there's stuff here, so just use an arrow key. Hit enter, and again, it's smoothed, so you can just let it fill all the way down. That is step 7, done. Step 8, okay, so historical forecast. So this is when we start working on the forecast itself. So we've done seasonal, we've done the trend, we've adjusted things. Now let's put the forecast together. So we need to go to G15 because we need to go one below where we have data, equals an open bracket, E14, which is the adjusted data from the previous period, plus F14, previous period's trend, close bracket, times it by D3. D3 again, it's because it's the previous seasonal index. Hit enter. I'll let that autofill all the way down. Now, I have decimals turned off in this row, and that's just to make the data a little bit more comprehensible. We're dealing in units of 500, 2000. You don't need to have decimal places. If you round up, if you round down, it's a difference of 1 unit. When you get to the end and you're actually doing your ordering, you can You can always order more, 1 unit more to compensate for the rounding, but in this scenario, you might as well just leave it to round to the nearest number. So that is step 8 complete. Okay, errors. Yeah, we need to track our errors. We need to know exactly how good we are at this. And so this one's probably the easiest one, equals our actuals of that period minus our forecast. Pretty easy. Okay, so right now if we take a look, we have a whole bunch of minuses, and then some pluses. Okay, so we can work with that. We'll refine that later. But that, for now, step 9 complete. Step 10. Okay, so step 10, we need to do our future forecast. This is what we've been waiting for. So we'll scroll down. We need to create a little bit of formatting for our spreadsheet. So we need to continue this date down for all of 2020 so that we make sure that we can capture our forecast. So this is what we want. We want this and this. That's what we're after here. Now, continue to bring that down. Sneezy, you can't bring this down. Can you bring this down? Yeah, definitely. You can bring that down. This, yeah, that can come down too. This, sure, bring that down. And then here, all right, so here is where it gets a little bit different. So here we're gonna go equals, open a bracket, E61, and we're gonna lock it. And then plus I62. Now I62 we'll talk about in just a second, but just put it in there anyways, times F61. I'll lock that one too. Close the bracket, times D50. D50 is our seasonal index for prior period. There it is. Okay, hit enter. So what did we use? We can drag that all the way down. So over here we clicked on something, but I haven't talked about it yet. So this is what we call K. And K represents the number of periods in your forecast. So we can bring these, make them a little bit more visible. So you'll just label it K, period 1, 2, 3, 4, 5, 6, all the way until 12, which is all we're forecasting for this. So this is just saying that this is the first month in the forecast, the second, so on and so on. So that's a future forecast complete. But in step 11, this is where we take a look at our root mean squared errors. So this formula is taking your errors. It is penalizing the biggest differences the most. And so instead of just saying, hey, taking an average of all these errors, you'll have some outliers and those outliers will just be washed away by the average. But if you do RMSE, those outliers are penalized the most. So you get the most accurate representation of the accuracy of this forecast. And to calculate that, we're just gonna go up just below the smoothing constants. We're gonna go equals. We'll use square root function, and then we'll do sum. We're gonna do sum squared of H15 to H61, which happens to be all the errors. Go all the way down. And then double the brackets and divide it by everything that's there. So we'll use the count. Exact same field, H51 to H61. Sorry, and by 51, I do mean 15. And we'll hit enter. Now we have RMSE of 72. It is kind of awful, and we'll talk about that in a second on how we can optimize it and get it a little bit lower. We'll do that in the very next step. So that's step 11 complete. Here is step 12. So step 12 is where we make RMSE a little bit nicer to work with. This is where we make RMSE a little bit more accurate. So this whole forecast is going to get more accurate. Because if we can take a look over here, we have a really funky looking forecast going on, and it doesn't look so nice. We have a bunch of errors. So let's use these smoothing constants to optimize that. So for that, we're going to use Excel. We're going to go data, solver. We'll come up with this parameters. I've had some in here before. I'm just going to delete them just so that I can show you the whole process. When you open it up, it will look like this. And you're going to set your objective to RMSE, which is K6. You want to minimize it. You want the least number of errors. And you can do that by changing these three constants. Now, these three constants have constraints. So you're going to add the constraints. And that is that these constants must be less than or equal to 1. And these constants must be greater than or equal to 0. I'll hit OK. I'll hit solve. Hit OK again. So we started at 72. Now we're at 20.8. That is significantly better. Significantly better. And our forecast has just become far more accurate. Still a funky thing going on down here. I assume it's just where this graph is pulling data. Yes. So it has a period in here which does not count. So it's going to 74. Should just be going to 73. So the funky thing that we have going on here, just in case this happens to you, is just the date. So here it's just got the date formatting going on because I have my computer in one time zone and then recording in a different time zone. So we'll just drag to make sure it's got the same formatting going on, same date formatting. Okay, much better, much better. So here we have the two forecasts. So when I say the two forecasts, I mean we have the historical forecast, which is following the blue line, and it's trying to stay close to the blue line, as close as it possibly can. And then when the blue line ends and the orange begins, this is the future forecast. This is our goal. So there we have an optimized winter's forecast. Now let's go back and let's take a look at the last task that we have. So we've done create a winter's forecast. Beautiful. Now, so we're going to be interpreting these values as well. So we'll evaluate the forecast accuracy and we'll interpret what these measures represent and how we can use them. So let's go back over to our sheet and let's decide on what kind of measures we can use. So I already have some hidden away, so I'm just going to bring them up and we're going to talk about them. So these are some accuracy measures. We have MAE. So MAE is just taking the absolute average. So when we see a negative here, that means that our forecast is 213 above the actual. When we have a positive, it's the inverse of that. Now, this takes the absolute value of all these, so it gets rid of all the negatives, and it just says, hey, what's your total amount of errors? And so each error represents 1 unit. So here it says that we're forecasting 213 above what we should have. So this is 213 units above what we should have had. And MAE just says this is total errors. MAPE, this one is very useful because it's easy to interpret, and this is the one that we use when we're evaluating one forecast method to another forecast method of the same product. We want to make sure that we use this one because it's a percentage. The other ones are units. So unless the unit is exactly the same and the demand is the same, This one's just easier to interpret. It's a percentage. Everyone understands percentages in the same way. When you're talking about units, you need a little bit more context. So use this one when you're comparing different forecasts together. Pick the one with the lowest percentage that represents the least error. Then we have MSE, mean square root of errors. So this is just, so you're summing them, you're squaring them, then you're dividing by the total count of them. So that is another method of doing it. And then our preferred method is RMSE. And this is taking MSE, mean square root of errors, and square root of them. And so by doing this, you're penalizing the greatest errors the most. And we typically do several different forms of forecasting accuracy measures just so that we can get a good understanding of where exactly the errors are. So when we make a forecast, we'll do the forecast and then we'll check its accuracy and we'll see if we can optimize it. And if we have it optimized, then we'll see if we can maybe use a different forecast method. And then we'll compare using MAPE. Now there's other accuracy measures, we're just focusing on this one in this video. Now we have another product here, Breezy. So we did Sneezy, and we have Breezy left to forecast. And this one is going to be significantly easier because all you have to do is you just have to copy it over, create a copy, delete all the data that you had for it, for Sneezy, go back over, grab Breezy, Control C, cover up Sneezy with Breezy. Look at that. You're done. Almost. You do have to optimize this again because it behaves a little bit differently, because that's a forecast. That's looking pretty funky over there. So let's go back to data. Let's go to Solver. And the beautiful thing about Solver is it already has everything saved for you. So just hit solve. Hit OK. Go over. Okay, it's still funky, but at least, optimized and funky. So here we have our two different forecasts, one for Sneezy, one for Breezy. If you want to figure out what the total is, which you anticipate stocking for the next year, just add up the two values and then you'll get your total. So this is how you do a winter's forecast in Excel. Thank you for watching. Please subscribe, hit the bell icon, do all those things. Follow me on Patreon, and thank you.